Welcome to today's video. Last time we left when we are talking about the inverter. We saw what's the work of inverter, converting the DC from the
solar panel
to AC. And also we said it charges also the battery bank. Your battery bank can be several batteries connected in parallel. Do this. You can use this here. This is a bus bar, positive here, negative here. Through this trunk there are wires inside. This is the circuit breaker to the battery bank, 125 volts DC, because our inverter is 3 kVA. This is a 3 kVA inverter, so we have to protect it using 125. That is 3000 divided by 24 volts. You see, it's about 125 amperes. That's why we have this circuit breaker here. So if our inverter draws more than 3000 watts or more than 125 amperes, this one will trip. That is protecting our inverter and also the battery bank. That's one of the protection to protect our inverter. The others are in these two boxes. Here is the DC box, and this is the AC box. It is important to separate the two. You know, DC it has a very strong field around its cables. You understand? DC carrying conductors have a very strong magnetic field around them, or electromagnetic field around them. So we separate the two, AC and DC. In the DC box, this is where you receive our voltage from the solar panels. They come first to this is an SPD. That is surge protection device. This one protect if there is lightning strike on the panels, on the solar array, it will be grounded. You see here below, it is connected to earth. Positive and negative here. Then the other side is earth. Here is earth. Also we have these are two fuses. These fuses, you can have the correct one. Like now, these ones are 30 amperes each. That you can calculate the current coming from your solar panels to know the size. Also, you have a circuit breaker. This is a circuit breaker. This is a circuit breaker. We also, this is one array. This one array is panels connected in series. Also, this another array. This one is not connected, that's why it is off. Also, you have two bus bar, positive bus bar and negative bus bar. Both arrays can be connected now, combined now. You combine both this array and this array, and you have one output to the inverter. One positive, one negative to the inverter. PV input here. This is the PV input. The PV voltage should be less than the VOC. Remember, here at the side, you are given the VOC, like maximum VOC, like here it is. Maximum solar voltage VOC is 450. So, they are 450 volts. So the power getting here should be less than 450 volts DC, which will go inside the inverter. Like right now, from the PV we are getting 339 volts from the PV. you see it is below the 450. So we are good to go. Although right now the system is not charging because the batteries are already full. If you do the right calculation of your battery bank, it will be full by 11 because it will just require only 5 hours or 6 hours of sunlight with no cloud cover. So we have finished the DC box. We come to the AC box. AC box, we have power from the grid. If you are using the hybrid inverter, like here, this is a hybrid inverter, you can have power from your utility as standby. This standby power, you can have it. So it comes first to the surge protector device. This, if an lightning occurs somewhere outside, the system is protected. You also have the circuit breaker. Then ABS. ABS, most of the time, this circuit breaker will protect you from high current, 32 amperes and above. But voltage will not be protected from other voltage by this circuit breaker. So you put an ABS. You can set it. If the voltage goes below 200, it will switch off. If the voltage goes above 250, it will switch off. So it must be in there between. So and also the current, the maximum current which can come to the inverter is also set there, which should be the appropriate, like 230. This one is a 3000 inverter. So you do your math. 240, 3000 divided by 240. You see the current which is safe for this equipment. So next we have this one are the input. So from here, after that power goes through the ABS. ABS is automatic voltage stabilizer. Automatic voltage stabilizer. Although most of the time it just cuts off, and it prevents your gadgets from under voltage and over voltage. So from the output from that comes to input here. Input here, all of them, live, neutral, and this is the earth, live, neutral. Make sure you have done it correct. These are the output to your items or your appliances. They come to the ABS here. Power from there comes to ABS here. This is protect your, if in case your inverter has a problem, it will not affect. So it comes direct to this first circuit breaker here. From the circuit breaker you come to the ABS. If there is high current from the inverter, this one will trip. Also, it will protect if one of your items have a short circuit, it will produce high current and this one will trip, and also ABS will sense the high current and trip. Like now, you see the total amount of power being drawn from the inverter is 230 times 1 can, that's about 230 watts. So not a lot of items are on. You also check the voltage. This is ABS can hold that up to 63 amperes. But our system is 3000 watts system. So 3000 divided by 230. You see how much current can provide here, and then you set it here. If your appliances require more than that voltage, it will trip and protect your inverter. It will protect your inverter. So this one protect your load, also protect your inverter from the load short circuit or overdrawing. Also it will protect your load from inverter in case your inverter is damaged and produce a lot of current. that power will not get to your items. So these are the providing, this one are providing power to different items in the system, like the lights, the fridge, whatever item you want, they can be provided power from. This is AC power now. Output is AC. From our inverter, we are getting AC out. This is our out, which comes here to this AC box. These are security items. Remember, even your solar array mounting rack should be grounded, and the grounding should be 1, not 2. 1 common. We should have a common. We should have a common earth. So like the road is 2, so the fans have gone quiet. They are quite noisy for this system here. So that is how we protect our system. Remember, which is very important, use especially these 2 fuses in a circuit breaker and SPD. SPD very important, can protect you from lightning. In case the lightning hits your solar array, it will be grounded. Remember, we said grounding should be properly done, or your grounding should be in 1 bus bar. 1 bus bar to a common earth rod, which you are going to hit outside your house. Should be a common earth. If you have in different points, it will give you a lot of problem, especially if you are using a TV in here. They have a lot of electromagnetic effect. So always ground your system and use SPDs. So power from the solar comes to SPD, the fuses, the circuit breaker, to your inverter. Then when it is changed to DC. It was DC, here it is DC. This is a DC box, so this one was DC. Goes to your inverter, changed to AC. AC then comes back. You have to go through the ABS, circuit breaker, and circuit breakers to each of your road. That is very important because solar items are very expensive. Please protect them. They may cost some quite amount of money, because SPD goes for 2,000. This one are about 120 each, 120 in Kenya shillings. This one goes to double pole, goes to about 2,000 or 2,500. All of these ones. Then here ABS goes to amount to 2,500. Double pole, the AC are very cheap, about I think 150. SPD 2,000, and this one each I think 150. ABS here is 2,500. So the AC items are commonly used, so they are cheap, but DC items are quite expensive. So this is how you protect your system. These are 16-way box, so that it can accommodate the 2 arrays. If you have a smaller, you get a small combiner box. They are called combiner boxes. They combine all your array here. The 2 arrays are combined to 1. This one, it helps you in distributing your power. Thank you very much, and see you in the next video.